So here are some real-world examples for this section. So the formula for speed is most commonly represented as speed is equal to distance over time. Rewrite this equation twice by solving for both d and for t. So on this left one, we'll solve for d. So I see that d is right there. I want it by itself. It's being divided by t. And so I can get rid of t by multiplying by t here, and then I'd also have to do that over there as well. And what this means is that the distance formula can be rewritten. The speed can be rewritten in terms of distance. And so I'm just kind of jumping this to there. And I'm going to have st. So that's already finished for what they're looking for there. Again, let's rewrite the formula from scratch. Speed is equal to distance over time. Now we could have used this result if we wanted to. That doesn't matter. It probably would be easier. Now I want to solve it for t. Well, here's the issue. T's in the denominator. And I can't really say I've solved for something if something's showing up in the denominator. So I'm going to multiply by t, which is really what we did in the original problem. But for different reasons now. We're doing it in this step to get rid of having t in the denominator so that I again have d is equal to st. Here I'm going to divide both sides by s so that I now have t is equal to d over s. So I could actually solve for time if I knew the distance and speed that something traveled. I mean, the equation can be manipulated really any way you want. Now, if you're wondering, well, why did I, even bother shuffling around there when really, if I would have kept the t here, then I wouldn't have had to have done it again? That's a perfectly legitimate question. We've done it both ways. We're moving on. Now, this kind gentleman who didn't mind me stealing his stock photo from visiting the most large yo-yo on Earth, I guess, the largest. Some people say largest, I say most large, apparently. It's 32.7 feet in circumference. What that means is that we can trace around this and label that with a capital C. Your image is black and white, so you might want to trace around it and then draw a little arrow or something with a capital C there. The formula for the circumference of a circle is c is equal to 2 pi r. Now, I'm assuming that means that whatever I'm doing, I should probably rewrite the formula they give me, where c represents the circumference and r represents the radius. So let's label this. CIRC for circumference. R is radius, radius. And we're told to solve the formula for r. Well, r is not by itself. It has 2 and it has pi with it, and they're both being multiplied. So all I have to do is divide both sides by 2 pi. And that means that the radius would be by itself, and that would be equal to the circumference divided by 2 times pi. Now, notice that I'm using an equal sign here. And the reason I'm using an equal sign is because I did not plug in the value of pi when it is approximately 3.14. I can still use an equal sign as long as I avoid rounding there. Now it says find the radius of the yo-yo. Well, even though we just have r is equal to c over 2 pi, I want you to rewrite that as r is equal to c over 2 pi. So that now when we go back, we can actually reread the problem, and we find, okay, it's 32.7 feet. I'm going to write equals 32.7 feet over 2 pi. And then down here, instead of writing equals, I'm going to use an approximate symbol, and we will not leave our answer in terms of pi for this one. And the reason we won't is because I'm looking for a calculator if you hear what I'm doing there. They've given us decimals, and if we have an answer in terms of pi for this example, we're not really going to be sure exactly what that means as far as how large or small it is. So I'm just going to round to 3.14 here, and it looks like I got approximately 5.21 feet. Since they gave us unit in feet, we would maintain that in feet. Yeah, that seems about right. So just for the heck of it, let's go back and label this R, and then we'll write 5.21 ft. So we converted the equation to R so that we could then just plug in and chug. Now let's say instead we had just used the original formula where C is equal to 2 pi R. Then we could have plugged in 32.7 and then just solve for it. And you might be like, well, that would be easier. And I would accept that. I would agree. That would probably be easier. But there's going to be times where we're going to want to do it the more challenging way because it's more abstract and lets us do more and more challenging types of problems. Physical science. Okay, the formula, blah, 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 blah. Before I even read the problem, I'm just like, let me take this equation out. Maybe it'll make more sense once I've rewritten S equals 1/2 AT squared. So this is the distance. Let's go ahead and draw an arrow to S and write dist, that a free-falling object will fall near a planet or the moon in a given time t. Now this is the deal. This would be in seconds. In the formula, A represents the acceleration due to gravity. Now here's what they mean by a free-falling object. So let's sketch this to the right of our space. So here's the surface of a planet or the moon. So we'll just write planet or moon. And what they mean by a free-falling object this is what it's doing, and it's being accelerated by gravity. Now this would not be like a satellite that is traveling around the Earth. This would be something closer. It would be true for gravity, but it would be true for the satellites, but they're moving pretty darn quick. So S is equal to 1/2 AT squared. We're supposed to solve this for time. Nope, I'm sorry, I misread it. Solving it for acceleration, let's see what happens. Well, first off, we have this fraction, so let's get rid of our fractions, and this way I'm going to write it 2 times the whole thing, so that 2s is equal to 2 over 2, which goes away, so I'll just have AT squared. Now we can't have time over there, so let's divide by t squared, and I'll see that A is equal to 2s over t squared. And we'll box that. Now, it looks like they're telling us more. The free-falling object near the moon drops that many meters in 5 seconds. Now, let's think about what meters would be. Well, it wouldn't be acceleration. It wouldn't be time. The only thing that it can be is s, and we already labeled that anyway. So let's draw an arrow there and write s. And then logically, this has to be t for time. What is the value of A for the moon? So they want us to use what we just created, which was A is equal to 2s over t squared. Rewrite it. Now what they're doing is they're kind of guiding us towards the result. They told us to solve for A, so now logically we have to use this. Later on that might not always be the case. So here I have A equals, I don't need to show that A, but I did this time. I know it's implied. And I'm going to have 2 times s, which is 5. Whoops. I got confused there, right? Because s made me think of seconds. S for this is position. So 2 times the distance, 20.5, over 5 squared. And maybe in your head you're like, well, 20.5 times 2 is 41. Maybe you're pulling a calculator out. And that's going to be over 25. Now here I'm not going to simplify this because I'm interested in knowing what this means for how fast something falls on the moon. So now the equal sign gets written, and I can do this based on the numbers they give me, although guess what, this is definitely not exact. 1.64 meters per second squared. Let's go back and think about why that is. Well, the units for s is meters, right? And the units for time were seconds, but it's not just time, it's time times time, and that means that's why you have that second squared. So 1.64 meters per second squared. That means that that's the acceleration that an object falls at towards the moon. Now compare that with what I know is gravity on Earth, which is 9.8 meters per second squared. So obviously Earth's gravity is a little bit more significant than the moon because the Earth is a much larger object, and larger objects have larger gravitational pull due to their larger mass. Here is the assignment for these problems, and accomplish it according to your teacher's instructions.